Unit 5 is all about reactions. Now the title of it is Holy Moly, look at these reactions. We're going to divide it up into two parts. We're going to look at reactions, and then we're going to look at the math that goes along with the reactions. So the holy moly part will be in the second half of this unit, and we're going to focus on reactions for the first half. So a chemical reaction is the process by which substances change. So remember, you start with reactants, and they undergo a chemical change, and they form products. So a good way to remember that reactants are always on the left is that reactants are at the rear of the arrow, R and R, and that it points to the products, P and P. So reactants are always on the left of the arrow and products are always on the right. A reaction, or the equation that goes along with this, represents the identities and the amounts of your reactants and products. The law of conservation of mass, remember, means that the mass you start with has to equal the mass you end with. So that's why we balance chemical reactions. And that's what we'll be doing in the next lesson, is balancing. Now going back to Unit 1, we know that there is a chemical reaction taking place when we have one of 4 indicators. So really we need a number 4 here. The first indicator, something that you might see during a chemical reaction, is a color change. Remember, it has to change color, not just the shade of a color. So you can't go from Carolina blue to Duke blue. That's not a change in color. It has to go from red to blue or black to hot pink. There has to be a color change. The second indicator we have is the formation of a gas. And so if we're in the lab and we're doing some experiments and we have the formation of a gas, we might see that by seeing bubbles if it's in a solution, or there might be an odor, but not all gases have odor, so you can't say that one of the indicators is smell because that's not going to be accurate. So forms a gas, and then we're going to see that possibly as bubbles or odor, or I guess let's put in the last way to know that. Is a loss of mass. But really we're not losing mass, it's just escaping into the atmosphere. So if you think about when you burn a heavy log and then you collect all those ashes and you weigh it again, the ashes weigh less than the log does. That's because you formed some gas. And it's hard to collect that from the atmosphere. All right, so we have color change, we have form of gas. The next one is that it forms a precipitate, which I abbreviate as PPT, a precipitate. And a precipitate is simply a new solid. So it's a solid product that is formed. And when we're in the lab and we're mixing two things together, we know that it forms a solid when it looks cloudy. Okay, so it's not going to chunk out like a piece of nickel is not going to come falling out and hitting the counter and you're going to hear it. It's just going to look cloudy because it's going to float around like a mud puddle. All that mud floats around until it settles to the bottom and then the water turns clear again. The last one that you have is a change in energy. And there was 2 ways to change energy. Remember, you have endothermic, which means energy is being absorbed. And exothermic, which means energy is being released. So endothermic, it feels cold. If it's endothermic and it's happening in the test tube would feel cold. If it's exothermic, then it would feel hot to the touch. So that's how we know, that's how we can observe an energy change in the classroom. Now, if it's light that is being released, that's more obvious. But as far as heat goes, you would have to feel the container it's happening in. right, so how do we know that there's a precipitant that is going to form? Remember, precipitant, abbreviated PPT, is a new solid. So you have your solution. Sometimes it gets suspended in there, and then as you let it sit, it all settles to the bottom. And so that's the precipitant, or the precipitate. You want to use the anion in the formula. So look at your reference tables on page 6. At the very top is your list of solubility rules. Now there's two lists there. The first one is for soluble, and soluble means it's aqueous in solution. So we use the AQ symbol. So next to the word soluble on page 6, you might want to write AQ, that it's aqueous. It dissolves in water. Insoluble means that it doesn't dissolve in water, so that's the S. And so it kind of messes people up some because they want to make soluble S for solid, but it's not. Soluble is AQ for aqueous. Insoluble is S for solid. If it's a part of the exception, it's going to be the opposite of what it normally would be. So let's look at some examples. Again, you have to be looking at your reference table, which is on page 6. And at the top, you're going to see on page 6 the solubility rules. Soluble means aqueous. It will dissolve in water. Insoluble means it will stay a solid. So AQ and S. You look at the anion, the second thing, and it says phosphate. So we're going to find our rules on phosphates, and it's over here. All phosphates are insoluble except group 1 and ammonium. So then we look to see what is phosphate with. Phosphate is with calcium. So this is group 2, which is not a part of the exception, so this is going to remain solid. Ammonium chloride. Find your rules on chlorides. Here it is right here under aqueous. So all chlorides are aqueous except silver, lead, and mercury. And since our chloride is with ammonium, it's not an exception, and we're going to write aqueous. Now we're going to find our rule on bromides. Here's bromides right here. All bromides are aqueous except silver, lead, and mercury. Well, look, we're with an exception. And when you're with an exception, it's the opposite. So while this would be aqueous, because it's with silver, it is now a solid. So silver bromide does not dissolve in water, and it will precipitate out. Next we have nitrate. All nitrates sitting right here. Notice that the word except is not given to us in that rule. So all nitrates are soluble. Doesn't matter who they're with. They're always soluble. All right, carbonate. Carbonate right here. All carbonates are insoluble except group 1 and ammonia. Calcium is not in group 1 nor ammonia, so it's going to stay solid. All right, use your page 6 and try numbers 6 through 10. We already did 1 through 5, so pause the video and try 6 through 10. All right, remember you had to use that anion, those second things in the formula, and there's the answers. If you have questions, let me know by filling out the Google form, and then try your luck with the questions on the Google form.